Greetings, fifth grade mathematicians. Today we move into dividing decimals. Please don't be intimidated and keep that growth mindset because you possess a lot of the skills that you need to be successful with this unit. We're back in person and I could give you in the moment feedback. So we're going to get through this and you're going to do a great job with this and you're going to feel really confident by the end of this topic. This lesson, like last topic, focuses first with understanding place value patterns to help you, one, estimate, but really do the division without having to roll up your sleeves and go through an algorithm. So we're going to be using the mental math and place value patterns to divide decimals by a product of 10. So here's our guiding question right here. How can you divide decimals by powers of 10? Chandra wants to cut a cloth into 10 strips. All of the strips should be the exact same size. How long will each strip be? Let's look at the given information. So we know that the strip, the material, is 89 and 5/10 centimeters long, and it's going to be cut into 10 equal strips. So we have to think of what is the expression going to be to help us solve this problem. So we have our original value of 89 and 5/10, and we're going to split it into 10. We know that splitting into even groups is division, so we're going to divide it by 10. So we're looking at solving 89.5 divided by 10. A quick reminder about exponents is right here for you. Remember, when we have an exponent that is a 10 as the base, this is called the base. The exponent is the little number here. What this is telling me is to multiply the base by the same number as many times as that exponent. So 10 squared, or 10 to the second power, is 10 times 10. And 1 to the first power would just be 10. If you had 10 to the fourth power, that would be 10 times 10 times 10 times 10. And when your base is a 10, you're having multiples of 10. Think about it. 10 times 10 is 100. 10 times 10 times 10 is 1,000. 10 times 10 times 10 times 10 is 10,000. And these are the types of problems that make it easy to do division when you have those bases of 10 or those multiples of 10, those numbers ending in those zeros. And that would be the 110, 100, 1,000, 10,000, so forth. You're able to just simply move that decimal point. So let's look at what we would do here. So to find 89.5 divided by 10, we have to think first of what are we doing? Use your number sense. So if I had a number like 150 divided by 10, this number would not grow. You're taking 150 and splitting it into 10 equal groups. So if I drew my bar diagram, I would have 15 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the reason why I would have that, because if these 10 equal groups, if you add them together, would equal 150. The nice thing about it, and coincidentally that you will see that it's 15, is it's kind of going back to that principle that we did with multiplication, where when you have a power of 10 divided by another power of 10, you can cancel out those zeros. It becomes 15 divided by 1, which is 15. But why? Why does it do that? And the answer to that would be place value in our number system is called a base 10 system. And you learn from the time you were in kindergarten that when you have 10 ones, you can bundle them up, you have 110. If you have 10 tens, you can bundle them up and you have 100, and then all the way up to infinity. This gives us a nice little pattern and structure to work with when we are doing this type of work with these multiples of 10 and we're dividing these decimals. And what we're going to do is we're going to take a number divided by 10 and shrink it because we know that it's less just from this example I gave you. And to do that, we're just going to move the decimal point to the left because it decreases the number's value. So let's look up here my place value chart. I'm not always the biggest fan of red, and we're moving to blue. We have 89 and 5/10. So I put this here because I think this is a good review to remember. This is my decimal place values: tenths, hundreds, thousandths, ones, 10, hundreds, thousands. So we have 89, 8 tenths, 9 ones, and 5 tenths. And we're going to divide that by 10. So thinking about that example on the bottom I gave you, when you have 150 divided by 10, you know that number is shrinking. We're going to move this decimal point to the left. How many times? Just one, because we're just dividing it by 10. For every time you divide it by a 10, you're going to move it to that place value to the left one time. So if it was divided by 100, which is 10 times 10, that's another 10, you would move it 2 times. If it was 1,000, you would move it 3 times to the left. If it was 10,000, you move it 4 times to the left. We did this similarly with multiplication, but we moved to the right. So this time we go when we know that division is to the left, multiplication is to the right. So 89 divided by 10 is simply just moving this here. And my new number becomes 8 and 9 tenths. I'm sorry, 8 and 95 hundredths. 8.95. See, I moved it one time, 8.95. I just rewrote it down here so you can see and write it a little bit easier. 8.95, same thing. All right, let's look at some more here. Notice the patterns in this table. So if we look at here, they give you the standard form, the exponential form, and examples. So we have 89.5 divided by 1 is 89.5. That's identity property. Anything times 1, anything divided by 1 is itself. 100 divided by 1 is 1, 100 times 1 is 1. Look when you now divide this by 10 to the first, or 10. 89.5 divided by 10, that's the one we just did, was 8.95. Let's look at if we divided it by 100, or 10 to the second. Remember, this is 10 times 10, which is 100. They took the decimal place here and they moved it 1, 2 to get that decimal point right before the 8 to make it 0.895, or 895 thousandths. If they did it to 10 cubed, or 10 to the third power, it's divided by 1,000. 89.5 divided by 1,000. And if you think about that, you have 89. If you just drop that decimal, you have 89 as a whole number, and you have 1,000 people. You do not have enough, really, to give someone a whole one, right? There's 89 of you, and let's say this, there's $89, and there's 1,000 people. Not all of you are going to, none of you are going to get a dollar if you divide it evenly. You're going to get 0.0895 of a dollar, or 895 10,000ths of a dollar, which is a fraction of a dollar. So if you see what they did here, they just moved that decimal point 3 times. But when you don't have double numbers over here, you're going to have to annex it. So if you see that, 89.5 divided by 1,000, what we have to do is we have to put some zeros in that place value. So we have one hop. Remember, we're doing 3 hops. 2, 3, and that's where that 0 comes in. And the new decimal point would be here. If you dropped that decimal point, it would be 0.0895. It's the pattern. If you did 10,000, it would be 0.00895. If you did 100,000, if you divide it by 100,000, it'd be 0.000895. So it's really no different than multiplication. You're just working the other way. The number's shrinking by a multiple of 10 each time. Look at the example here. 50.5 divided by 1 we know is 50.5 because it's an identity question. 50.5 divided by 10. What we need to do is we need to take 50.5 and we need to move that decimal how many times? If you said 1 in your head or out loud, you're correct because it's a 10, right? We move it 1 over. So my new number becomes 5.05. What about if I did it to 100? 50.5 divided by 100. 50.5. Oh, that's an ugly 5. Divided by 100. We're moving it how many places? Look at those zeros. 1, 2. You have 2 zeros there, so you should know we're moving it 2 spots. This is where a lot of you get into trouble here because you panic, I think. 1, 2. That's your new decimal point. Rewrite it. 0.505. 0.505 or 505 thousandths. Let's look at 1,000. How many zeros are in 1,000? 3. How do you write 1,000 as an exponent? 10 to the third. That 3 tells you those are your steps. There's your 2 steps you need your hops. There's 1 hop. That exponent's giving you the hops. So here's 50.5. We have to make 3 hops to the left, to the left, to the left. All your stuff is going to the left. 1, 1, 2, 3. This hop here, you got to fill in that 0. This is your new decimal point. 0.0505. 0.0505 becomes 505 10,000ths. So that's what we're doing today. This is math practice 7 in its finest. Look for and make use of structures. You're seeing patterns and connections. Remember, if you were multiplying by 10, you'd be going the other way. And you guys know that. Look at the multiples of 10 you know so well. 10 times 1 is 10. 10 times 2? I'm sorry, 10 times 10, not 10 times 2. 10 times 10 is 100. See your 2 zeros? 10 times 10 times 10 is 1,000. You're just adding those zeros. 10 times 10 times 10 times 10 is 10,000. You're just doing this by moving the decimal point to the left, and that's the same concept. It's just instead of going larger by multiples of 10, you're going smaller by large multiples of 10. Each of these pieces are getting tinier and tinier and tinier. If your candy bar was 50 feet long, you divide it by one person, you'd have 50 feet. If you had 50 feet candy bar and you divided it by 10 people, you'd have 5 feet each. If you had 50 feet candy bar and you divide it by 100, you'd have about 5/10ths of a candy bar. If you had 50 people and you divided 50 feet candy bar and you divide it by 1,000, you'd have about 5/100ths of a candy bar. So it's just that simple. Don't overthink it. Don't overthink it. Last thing here. You're going to see problems today that have exponents. There's 2 things you can do. Just simplify and understand that exponent. So this to me right here is divided by, we know 10 to the second power is really 100, right? So we're just taking this number and we're dividing it by 100. So you could just move it to the left, not the right, 2 spots. So here's your decimal point right here. You could go 1, 2 and rewrite that as 77.70. You can even drop that 0 and just have it 7.7. Or you can say, I know 7,770 divided by, that's not what I wanted to say, 7,770, not 777. 7,770 divided by 100. Knowing that whole balancing idea, I could cancel out these zeros. And I rewrite that as 777 divided by 10, okay? And then I could start thinking about doing that as division. But to me, that's an extra 3 steps when you just can move that decimal point. I do want to caution you though, this only works when you're working with multiples of 10. All right, go ahead now and turn to page 301 and work on your solve and share.